In this section, we're going to be going over frequency distributions and other statistical graphs. So starting with frequency distributions, there is usually going to be a lot of data to analyze at once. So when the amount of data is large, it's usually going to be in the statisticians or whoever's studying the data in their best interest to construct what's called a frequency distribution. So a frequency distribution is a listing of the observed values and the corresponding frequency of occurrence of each value. So for the definition of frequency, it is the number of data entries that are going to occur for a given value, or it can also be for an interval. So let's see an example here. So for example, the number of children per family is recorded for 64 families surveyed. Construct a frequency distribution for the following data. So all of these numbers here that are given to us are going to be the number of children per family, and there's 64 total numbers here for the 64 families. So a frequency distribution is going to be a table. And on the left column, it's going to be the possible observed values. So that's going to be all of the possibilities in our data. So our data looks like it ranges from 0 to 9. So the observed values are going to be 0, 1, 2, 3, 4, 5, all the way to 9. And what we are going to do is count how many of these values occur inside of our data set over here on the left. So for 0, and that's going to be the frequency on the right, which is going to represent the number of families that had that many children. So in our data on the left, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 families had 0 children. And then for 1, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 families had 1 children. For 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 families had 2 children. And for the number of families that had 3 children, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And for 4 children, 1, 2, 3, 4, 5, 6. 5 children, 1, 2, 3, 4. 6 children, 1, 2. 7 children, 1. 8 children, 2. And 9 children, we have 1. Okay, and a nice check here is to add up the frequency. If you add these up in the right column, they're going to add to 64, which makes sense because that's the total number of data entries we had on the left. Okay, so that's actually our frequency distribution. So we're not always going to be doing it the way that we just set it up. Often data is going to be grouped in classes for the left column. Classes are just going to be numerical intervals, and this is going to provide information about the distribution that might be difficult to see if the data were ungrouped. So we're going to be grouping these up in intervals this time. So here are some rules for grouping data with classes. First rule is that the classes should be the same width. So the interval should be the same size for each class. The classes should not overlap, and each piece of data should belong to only one class. So for example, if we have the numbers 0, 1, 2, 3, 4, 5, all the way to 26, and we want to split them up into 6 different classes, and once again that means intervals, we can use the classes 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and 25 to 29. So these classes do not break those rules. The classes have the same width, and the class width is actually 5 here. And that's because there are 5 integral values that are in each class. So even if you subtract them for like 4 minus 0 for the first class, that gives you 4. That's not what you're supposed to do to determine the class width. You count how many integral values are there. So that would be 0, 1, 2, 3, 4, which is 5 total. So each class has a class width of 5. The classes do not overlap. It goes from 0 to 4 and then 5 to 9 and so on. And each piece of data here will only belong to one class, and that's kind of because of the fact that they do not overlap. So when we have our classes, we have a smaller number to a larger number. The smaller number is called the lower class limits, and the larger number is the upper class limits. So the way that we can actually find the class width, if it's not explicitly given to us, the class width here was 5. And the way that we can find this is by subtracting the first lower class limit from the second lower class limit. So that would be 5 minus 0. That gives us a class width of 5. And like we mentioned, since classes cannot overlap, the next class has to start immediately after the previous class ends. So that means that the next class's lower limit has to be directly after the previous class's upper limit. So that means, for example, the first class ends at 4. That means the next class has to start directly after that at 5. Second class ends at 9. Third class starts right after it at 10, and so on. So if sometimes we're going to want more classes, sometimes we'll want less classes. If we want more classes, we're going to make the class widths smaller. If we want fewer classes, that means we would make the class widths larger. And two more sort of definition type things here before we see an example. The modal class of a frequency distribution is going to be the class with the greatest frequency, and the midpoint of a class, which is also called the class mark, but I'll be referring to it as the midpoint of the class, is found by adding the lower limit plus the upper limit and dividing by 2, which should make sense. That's just taking the average with the lower limit and the upper limit. Okay, let's see an example here. A hot dog vendor is interested in the number of hot dogs he sells each day at his hot dog cart. He keeps track of how many hot dogs he sells for 32 consecutive days, and that is our data shown below right here. This is the number of hot dogs that he sold per day. And we want to construct a frequency distribution, letting each class have a width of 1. Okay, so let's start by setting up our frequency distribution table. For the left column is always going to be the observed values, which is what the data represents. The data represents the number of hot dogs sold. And on the right, once again, this is going to be the frequency. So it's going to be how many times these numbers pop up in our data set, or how many times they occur in the data set. And what this actually represents in this case is going to be the number of days. Okay, so for a class width of 1, that's actually very easy whenever that happens. That pretty much means we just start with the minimum value and we just count on up to the maximum value. We just have to keep on adding 1. So it goes from 15 to 29. So let's go ahead and fill that in. Okay, so we have our numbers from 15 to 29, and now we just have to go to the data and count how many times each one of those values appear, and that's going to be the frequency for that class. So for the first one, we have 15. 15 pops up 3 times, so that's going to be the frequency. 16 pops up twice. 17 doesn't pop up at all, so that's going to actually be a frequency of 0. 18 pops up 3 times. And 19 pops up 4 times. And for 20, we'll do a couple at a time here. 20 pops up 3 times. 21 pops up 5 times. So that was 3, and 5. And let's take a look at a couple more at a time. 22 pops up twice, 23 pops up twice, 24 pops up once. So that's going to be 2 for 22, 2 for 23, 1 for 24. And for the next ones, 25 pops up twice, 26 pops up once, 27 twice, 28 once, 29 once. So we go ahead and fill those ones in. That was going to be 2 for 25, 1 for 26, 2 for 27, 1 for 28, and 1 for 29. So this big table here represents the frequency distribution for this data set. Okay, let's do one more example like this. So for example, the following data set represents the family income, representing thousands of dollars, of 15 randomly selected families. So we have this data set. So for example, 46.5, that represents $46,500. And we're going to construct a frequency distribution where the first class is an interval this time. So the first class is 31.5 to 37.6. So let's go ahead and set this up. So on the left, we're going to have income, because once again, it's the observed values. It's the actual values for each individual data entry. And then on the right is going to be the frequency. And the frequency here is going to represent the number of families. So let's go ahead and fill in that first class. It's 31.5 through 37.6. So now the question becomes, how do we fill in the remaining classes just given this one class? So we know that the next class has to start directly after where the last one left off. The last one left off at 37.6. That means the second class has to start at 37.7. And we're going to figure out the class width here by subtracting the first lower limit and the second lower limit. So this is from that second page, I believe. So for the width, the class width, every class width has to be the same. That's why we have to do this. So the class width is going to be 37.7 minus 31.5, which is going to end up giving us 6.2. Okay, so that's going to be a class width of 6.2. And to fill in the rest of these, we kind of have two different options, ways of thinking it. We can either keep on adding 6.2 to the lower limits first and then fill in their corresponding upper limits, or we can do the opposite and fill in the upper limits by adding 6.2 and then fill in the lower limits next. So I'm going to fill in the lower limits first. So that means for the next lower limit, we need to add 6.2 to 37.7. So that's going to end up being 37.7 plus 6.2. That's going to give us 43.9. And let's do it again. Let's do 43.9 plus 6.2. And that's going to end up giving us 40, or actually that'll end up putting us into 50.1. So that's going to be the next lower limit. So it does get a little bit tricky here for when we know when to stop. So our largest value, we have to stop whenever our largest value is going to be contained in the last class. The largest value looks like it is 65.2. So that means our last class should end directly after that. So what I'm going to do now is I'm actually going to switch over to the upper limits and start adding them over here just to make sure we don't do more than we have to. So if we keep on adding 6.2 to the upper limits, we're going to end up getting 43.8. Add another 6.2, we get 50.0. Add another 6.2, we get 56.2. Add another 6.2, we get 62.4. And add another one, and we should get 68.6. Okay, so I'm just going to finish it on the left now and add 6.2 to the left ones and get 56.3. Add it again, get 62.5, and that's going to be it for our left column. So actually, what we'll do going forward, just to make sure we don't get that issue where we have to jump to the upper limits next, we should just start by adding 6.2 to the upper limits first. We can do it to the lower limits like we were starting, but then it gets a little bit harder to see when we have to stop. So it's probably in our best interest just to do it to the upper limits first. Okay, so let's go ahead and tally these up. So let's count how many families had the income between 31.5 and 37.6. So that's going to be 31.8 and 35.5. So that's 2. And now let's count up how many families were between 37.7 and 43.8. That's going to give us 1 and 2 and 3. So 3 total. Now counting up between 43.9 and 50, that's going to give us 1, 2, 3, 4, 5. And now between 50.1 and 56.2, that'll be 1, 2, and 3. And then between 56.3 and 62.4, that will just be 1. And then lastly, between 62.5 and 68.6, that gives us 1. So here is our frequency distribution. If you add these up, we get a total of 15, which is correct because that's how many families we had originally. That's how many pieces of data we had. And just for the sake of practice here, let's recognize what the modal class is. The modal class is going to be the one with the largest frequency, which was going to be 43.9 to 50. So that's the class that had the largest frequency or the largest number of data entries falling within that class. And also, just for one more practice, let's take a look at the midpoint. The midpoint of the modal class, just so we don't have to do all of them. So the midpoint of the modal class is going to be 43.9 plus 50 divided by 2, which gives us 46.95. So we're going to be using that in a little bit. Okay, so it's best to start off by first, in this case, putting that first class down because that's what was given to us. Find the class width by knowing the next one has to start directly after where the first one ended. And then you can just keep on adding 6.2 down the right and 6.2 down the left. And we know where to stop because our largest piece of data was 65.2. Since 68.6 was larger than our largest piece of data, we knew to stop in that class. Okay, let's move on to histograms. Histograms are graphs, and they're going to be used to illustrate frequency distributions. So the observed values, which was our left column that we were just doing, the observed values are going to be on the horizontal axis or the horizontal scale, and the frequencies, which was the right column that we just were doing, is going to be on the vertical axis or the vertical scale. And a bar is going to be constructed above each observed value or class, which we can have either one. and that's going to indicate the frequency. It's going to go up as high as the frequency for that class or value. And the horizontal class does not need to start at 0, but the vertical scale does need to start at 0. So let's see this example here where we just have our observed values and we don't have to worry about actually writing out a class here. So we have the number of children for the observed values and the number of families, frequency on the right. So let's go ahead and set this up. So it's always going to look something like this, and the vertical axis is going to be the number of families, it's the frequency. Horizontal axis is the observed values, which is the number of children. And let's just label this graph also. This was the number of children per family. Okay, so let's look at the number of observed values. Let's fill out our axes, put some numbers on them. The number of observed values went from 0 to 9. So this one will start at 0 for the horizontal axis, and it's going to go all the way up to 9. So let's just count it. We'll start at 0, actually. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can label them starting at 0. Okay, we have them all labeled 0 through 9. And for the frequencies, it has to start at 0, and it is going to go all the way up to, it looks like 18 is the largest value. So let's just have this go up to 20. So if we're going up to 20, let's say 20 is all the way up here. The way I like to do it is cut it in half. If I'm doing it by hand, half of 20 is going to be 10. Zoom in a little bit. And then I cut that in half. Half of 10 and 20. The midway between 10 and 20 is 15. Midway between 0 and 10 is 5. And then we can just fill in the rest. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so now all we have to do here is put in our bars for each individual number of children, going up to the number of frequency for that individual observed value. So the first one is 0, 8. So we're going to make a little bar going up to 0, 8. So it looks something like this. And the next one is going to be 1, 11. So the bars here should be touching. So it's going to be 1, 11. So that'll look something like this. And then for 2, we have 2, 18, which will look like that. And then 3, 11. And 4, 6. And then 5, 4. And 6, 2. And 7, 1, 8, 2, 9, 1. Okay, so this is a nice visual. This histogram is a nice visual of this distribution of how many children people have per family. So you can see that it looks like most people have around 2, and then the further you get away from it, especially to the right, the less and less people have that many children. Let's do one more example for a histogram. So we have this frequency distribution, and it represents the one-way commuting distances for 70 workers, and we want a histogram. So the first thing that we should recognize is that we don't have just observed values here. We have classes. We actually have intervals that we're going to have to worry about. So let's go ahead and start by setting up our axes. Okay, so we have our axes, we have our horizontal and our vertical. Our horizontal is the classes in this case, the actual values. So that's going to be the distance in miles. And then the vertical axis is going to be the number of workers in this case, because that is the frequency. So let's go ahead and fill in for the frequency. Let's fill in the values on the vertical axis. So it looks like it goes up to a maximum of 24. So let's have ours go up to 25. So the way that I would just do this by hand, I would start with maybe 20 and then chop 20 in half. And then, so same thing I did last time, 15, 5, and then just add another one on. That's the same length for 25. Okay, and I'm just gonna fill in the ones real quick. Okay, and it'll look something like that. So it looks pretty good for the vertical axis. You can also put little arrows if you want on the ends of the axes, just representing that technically they keep on going. You don't have to do that though. So now when we're filling out the horizontal axis, it's a little bit harder because we do not have individual observed values. We have intervals this time. So we could use those intervals as the lower limit and the upper limit to put those on our horizontal axis. What I like doing here is actually using the midpoint. So let's calculate the midpoint for each one of these intervals. So I'll just go ahead and do the first one over here on the side, and then we'll just fill them all in. So the midpoint is going to be lower plus upper divided by 2. That's going to give us 8 divided by 2, which is 4. The next one is going to be 8 plus 14 divided by 2, which gives us 11. 15 plus 21 divided by 2 gives us 18. And then here are the rest of them. So for the class width for each one, the class width is 7, right? Because you subtract the lower limits. 8 minus 1 gives us 7. So since the class width is 7, if we know that and we find the first midpoint, we can actually just keep on adding 7 to it. So 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 7 is 25, and so on. So we can actually use that class width to help us find the rest of the midpoints. Okay, so let's go ahead and write those down here. So that's going to be 4, 11, 18, 25, 32, 39. And I'm just going to start it about right here. So 4, 11, 18, 25, 32, and lastly 39. So once we have these in here, then it's pretty simple. We just do exactly what we just did. And for 1 to 7, that had a frequency of 15, so we draw a bar. So something like that. And then for the next one, 8 to 14, that's the midpoint of 11. We go all the way up to 24. So something like that. And then for the next one, midpoint of 18, interval 15 to 21, it goes up to 13. Next one, it goes up to 8, and then 5 and 5. Okay, so this is our frequency histogram for the one-way commuting distance. And once again, we labeled them with midpoints, which in my opinion just looks a little bit cleaner for the horizontal axis. You could also label them with the class though, the actual interval, if you want to. Okay, so 2 more kind of small things here. We have 2 more types of graphs. The next one is a stem and leaf plot. So the only issue with a frequency histogram is that the actual data is not part of the histogram itself. We just use intervals, and that's when we know the data is between those intervals, but it doesn't tell us what the actual values are. So a stem and leaf plot is going to be a tool or a graph here that's going to organize and group the actual data, and it's going to let us see the actual values, the actual trend in the values. So to do this, we are going to essentially make a 2-column table where each value is represented with 2 different groups of digits. The left column is going to be the stem, and the right column is going to be the leaf. So typically what we're going to be doing, this isn't always the case, but typically the rightmost digit is the leaf, and then all of the digits to the left are going to be the stem. So there's usually only just one digit for the leaf, and then everything to the left of it is the stem. So let's go ahead and see an example. So the table here indicates the ages of a sample of 20 guests who stayed at Captain Fairfield Inn Bed and Breakfast, and we want a stem and leaf plot. So it's going to look something like this with two columns, the stem column and the leaf column. So since the original set of data here is all two-digit numbers, the stem is going to be the first digit and the leaf is going to be the second digit. So first, let's take a look at find the minimum and maximum value. It looks like the minimum value is 27 and the maximum value is 72. So for the first stem, it's going to be 2, and then the last stem is going to be 7, and we're going to fill out everything until we get to 7. So 2, 3, 4, 5, 6, 7. So these are our stems. They represent the first digits of our numbers. And now the leaf, each leaf is going to represent the second digit of the number. So we have a 27. So what we do is we write 7. And we also have two more. We have a 28 and a 29. 28 and 29, we just put it right after 8, 9. So this first row represents 27, 28, and 29. So let's look for 30. We have 31, 32, 39. So 1, 2, 9. And as you realize, it's good to put them in order for the leaves. And for the 40s, we have 43, 44, 44, 45, 47. So that is 44, and it happened twice, so we have to write it twice. And then, oh, I skipped 43. 43 first. 43, and then 44, 44. And 45, 47. And then for 50, we have 50, and 56, 58, 59. So that's going to be 0, 6, 8, 9 for 50, 56, 58, 59. For the 60s, we have 60, 62, 68. So that's 60, 62, 68, 0, 2, 8. Lastly, for 70s, we have 71, 72. So a 1 and a 2. Okay, so that sums up all of the data here. So you don't really need to write stem and leaf at the top if you don't want to, but you can if you want. It is also good to have kind of like a little bit of a key. And the key here is to tell you what these numbers actually represent. All you have to do is use one of them. So I'm just going to put key, I'll label it key, and you put 2, 7. So I'm going to use just this first one right here, 2 and 7, and we're just going to say what it represents. It represents the number 27. So it's probably obvious for us right now that it represents 27, but sometimes these can be decimals, maybe 0.27. You wouldn't put the decimal in there, so you would have to use the key to have so you know exactly what it represents. Okay, so you can sort of see like how the data spread out. It looks like a lot of it's right here in the middle. And we did this by using the actual data values, unlike the histogram. Okay, let's do one more thing. Pie charts are often used to compare parts of one or more components to the whole using percentages. So for example, a random sample of 500 consumers were asked how they pay for their purchases. The circle graph, or the pie chart, so that's another word for pie chart, is circle graph, below shows their responses. Since the total circle always will represent 100%, the sum of these sections should be 100%. If you added these together, you would see that they are. So you can see that it's a nice visual representation here using percents, and they're typically colored in with these slices as well. So cash, 40% of the customers paid in cash, 25% paid in debit cards, 18% paid in credit cards, and so on. Okay, so relatively simple, but it's definitely a good visual, especially when it's color coded, because automatically you can see that cash was the most. So let's do an example here and see what kind of question we can do with these. So let's say 800 people who attended a Ringling Bros and Barnum and Bailey circus were asked to indicate their favorite performance. And this circle graph down here, or pie chart below, shows the percentage of respondents that answered tigers, elephants, acrobats, jugglers, and other. And we want to determine the number of respondents for each category. So we actually want the number of respondents. We're given the total number is 800, and we are only given a percent. So let's go ahead and just break this down into a little table. So we're going to list down all of the options for performance. We have tigers, elephants, acrobats, jugglers, and other. And then we're going to determine the number of people for each one. So the way that we actually do this for determining the number of people given a total number and the percentage is we just multiply. So for tigers, we can see that not the majority, but the largest percentage out of these options enjoyed tigers the most. So what we do is we multiply the total number of people by the percentage as a decimal. So 38% as a decimal is 0.38. You have to move the decimal to the left 2. So instead of 38, move the decimal to the left 2, it becomes 0.38. You multiply that by 800, and 0.38 times 800 gives us 304. And then we do this whole entire time now. So next for elephants, 26% of people liked elephants. 26% as a decimal is 0.26. We multiply that by 800 and we get 208. So 208 people liked elephants. For acrobats, so that's 17%, so 0.17 times the total. And that gives us 136. Jugglers, 14%, 0.14 times 800 gives us 112. And then lastly for other is 5%. As a decimal, that is 0.05. So if you have 5% and you move the decimal 5 to the right, 2 to the left, sorry. If you have 5% and you move it 2 to the left, you have to plop in a 0, so it ends up being 0.05. So that's 0.05 times 800, and that equals 40. So if you added these all up, the total would be 800, which is what we expect because that was the total number of people that were interviewed for this pie chart here. Okay, so that is it for chapter 12.2.